It looks like you are ready to take notes for Topic 2, Lesson 2, Water in the Atmosphere. Our guiding questions for this topic lesson are: what processes make up the water cycle? How does energy drive the processes of the water cycle? How does the water cycle affect weather? So we are going to also, later on, investigate how clouds and fog form. Our vocabulary for this lesson is water cycle, evaporation, condensation, dew point, humidity, relative humidity, precipitation, cycle. The connected questions are: circle the organisms in the photo. Do the organisms have any effect on the water in the stream? How does the grass in the photo affect the movement of water? How might the cattle affect the movement of water? Press pause and try and answer these two questions. Welcome back. Thank you for answering those previous questions. Now that we're ready to read, the first thing we're going to do is mark our text. I'm going to mark my text as my paragraphs as I go. So please hold on a second. Go hit pause and mark your paragraphs, number your paragraphs. So mine will be 1, 2, 3, number those paragraphs, and then come back and we'll get ready to read. 1, 2. So we're going to read and then we'll come back and do some marking more of the text. Please follow along with your eyes as I read through. Water enters the atmosphere. During a humid day, the air around you may feel moist and thick. On a clear, cloudless day, the air may feel dry. The difference between these feelings is caused by the amount of water in the air. Water is always moving between the surface of the earth and the atmosphere. This process is known as the water cycle. A cycle is any series of events that repeat in the same order over and over again. In one phase of the water cycle, water vapor enters the atmosphere through a number of processes. One of these processes is evaporation. During evaporation, molecules of liquid water in oceans, lakes, and other bodies of water are heated by the sun. The energy of the sun causes the water molecules to speed up and collide more often. As the molecules collide, some of them escape and enter the surrounding air. The stream in Figure 1 is not the only source of water for the atmosphere. Plants and animals also release water vapor into the air. In plants, water enters through the roots, rises to the leaves, and is released into the air as water vapor. This is known as transpiration. Animals and people release water vapor into the air every time they breathe out or exhale. This is known as respiration. The figure on the right, Figure 1, it says water enters the atmosphere. Water is released into the atmosphere as water vapor from bodies of water such as this stream and living things such as grass and cattle. Now that we've read everything, we're going to do some marking of the text. So I have gone through and marked my text already, so I'm going to pull that up for you to take a look at. I have my paragraphs numbered, and what I found to be important were: water is always moving between the surface of the earth and the atmosphere. That would be something great right now to highlight. Well, I'm going to make my highlighter larger. It's not much larger. It's because I didn't have my highlighter on. There we go. This process is known as the water cycle. And then cycle was one of our vocab words. Any series of events that repeat in the same order over and over again is cycle. We've got evaporation is a process, and it's heated by the sun, causes the water molecules to speed up and collide more often. Molecules collide, some of them escape. And then I did down here put plants plants, water enters through the roots, rises to the leaves, and is released into the air as water vapor. This is known as transpiration. Animals and people release water vapor into the air every time they breathe out or exhale. This is known as respiration. I'm now on page 58, paragraph 4. Condensation. Recall that water vapor is a gas mixed in with the rest of the air. Condensation occurs when water vapor changes into liquid water. Paragraph 5. For condensation to occur, tiny particles must be present in the atmosphere so that the water has a surface on which to condense. Most of these particles are salt crystals, dust from soil, bacteria, or particles contained in smoke. During condensation, molecules of water vapor mix with these particles. Paragraph 6. Temperature is also a major factor in condensation. Warm air can hold more water vapor than cold air can. Therefore, as warm air cools, the amount of water vapor it can hold decreases, and the water vapor starts to condense. Liquid water that condenses from the air onto a cooler surface is called dew. The temperature at which condensation begins is called the dew point. If the dew point is above freezing, the water vapor forms droplets. If the dew point is below freezing, the water vapor may change directly into ice crystals called frost. Paragraph 7. One result of condensation of water vapor in the atmosphere is cloud formation. Clouds form when water vapor in the air condenses to form liquid water or ice crystals. When you look at a cloud, such as the one in figure 2, you are seeing millions of these tiny water droplets or ice crystals. When water vapor condenses near ground level, it can take the form of fog. Water can condense as dew on any solid surface, such as a blade of grass or a window pane. Figure 2. I'm over here now. Figure 2. Complete the diagram to show how clouds form when warm, moist air rises and cools. Use the following terms: evaporation, cooling air, condensation, and particles. Go ahead and pause this. Take a moment to try and see if you can do this in the picture to the right, and we'll see how it goes here and come back in just a minute when you're done. We're now going to take a moment to go ahead and mark our text. So I have it underlined and highlighted. You do not need to do both. I just really wanted it to stand out to you. So I have highlighted condensation occurs when the water vapor changes into liquid water. That is important for you to know. Also talking about, for condensation to occur, tiny particles must be present in the atmosphere so that the water has a surface on which to condense. Most of these particles are salt crystals, dust from soil, bacteria, or particles contained in smoke. During condensation, molecules of water vapor mix with these particles. Now, I'm actually going to add something here that I didn't highlight. So I'm going to change my color so it stands out. And that is, we do need to know, not only do these particles need something to lock onto, I actually did a little too much here. What they are locking onto is what we also need to remember. They need to have something like smoke, soil, or bacteria, dust, things like that, that they can latch onto to be able to form that condensation, okay? In paragraph 6, I'm going to highlight temperature is also a major factor in condensation. And then further down, the temperature at which condensation begins is called the dew point. You can highlight if you so want. It is actually really good. The dew point is above freezing. The water vapor forms drops. If it is below freezing, the water vapor may change directly into ice crystals called frost. You're not required to do the green. It's not going to hurt to do it. In paragraph 7, I did do one result of condensation is condensation of water vapor is the atmosphere is cloud formation. So we're actually talking about clouds being formed now. I didn't actually get it there, so let me get that. There's a lot in this paragraph that's important. Clouds form when water vapor in the air condenses to form liquid water or ice crystals. And then I also thought when water vapor condenses near ground level, it can take the form of fog. Water can condense as dew on any solid surface. That's what we see on the grass many times when we walk outside and our shoes get wet. Please go ahead and finish marking your text and we'll continue on to the next. I will now be reading page 59, starting in paragraph 8. Relative humidity. Meteorologists often warn of high or low humidity during their weather forecasts. Humidity is the measure of the amount of water vapor in the air. The ability of air to hold water vapor depends on temperature. Warm air can hold more water than cool air. So, in their weather reports, meteorologists usually refer to the amount of water vapor in the air as relative humidity. Paragraph 10. Relative humidity is the percent of water vapor in the air compared to the maximum amount of water vapor the air can hold at a particular temperature. For example, suppose that 1 cubic meter of air can hold no more than 8 grams of water vapor at 10 degrees Celsius. If there are 8 grams of water vapor in the air, then the relative humidity is 100%, and the air would be said to be saturated. Similarly, the relative humidity would be 50% if the air had only 4 grams of water vapor per cubic meter. Paragraph 11. Relative humidity is a better reflection of how the air feels than humidity. For example, air that holds 4 grams of water vapor per cubic meter can feel moist on a cold day or dry on a hot day. Relative humidity reflects this feeling. It would be near 100% on a cold day and much lower on a hot day. Paragraph 12. Relative humidity can be measured using a psychrometer. It is a device made up of 2 thermometers, a wet bulb thermometer and a dry bulb thermometer. As shown in figure 3, a moist cloth covers the wet bulb. When the psychrometer is slung or spun around, air flows over both thermometers. The wet bulb thermometer is cooled by evaporation, causing the temperature reading to fall. If the relative humidity is high, evaporation occurs slowly and the wet bulb temperature does not change much. If the relative humidity is low, evaporation occurs rapidly and the wet bulb temperature drops by a large amount. Relative humidity is measured by comparing the temperatures of the 2 bulbs. This is what digital hygrometers and sling psychrometers, like the one shown above, are used to find relative humidity. We do have at the bottom, it's a reading check. It says, suppose the 2 thermometers on a sling psychrometer show almost identical readings. Was the psychrometer more likely used on a Florida beach or in an Arizona desert? Explain your answer. Please go ahead and try and answer the reading check. Hopefully you were able to answer that question. Let's take a look at what I did for marking the text. So in paragraph 8, I did highlight humidity is a measure of the amount of water vapor in the air. In paragraph 9, the ability of air to hold water vapor depends on temperature is really important, so I highlighted that. In paragraph 10, our topic sentence at the beginning is what we want to highlight. Relative humidity is the percent of water vapor in the air compared to the maximum amount of water vapor the air can hold at a particular temperature. Paragraph 11, again, it's our first sentence. Relative humidity is a better reflection of how the air feels than humidity. And in paragraph 12, it's once again our first sentence. Relative humidity can be measured using a psychrometer. And then I actually also drew an arrow over here, so I would remember what a psychrometer looks like. Now, if you move further down to our reading check, our answer we're looking for is, it is probably the Florida beach because it is by the ocean and more humid. Going into my next page, let's see, I believe I'm on 13, 14, and then 15. All right, paragraph 13, water leaves the atmosphere. Water is continually evaporating and condensing in the atmosphere, and this process forms clouds. When enough condensation occurs within a cloud, water droplets form. At first, the droplets are very small, but they grow larger as condensation continues. Depending on temperature and other conditions in the atmosphere, the droplets may grow heavy, enough that gravity pulls them down toward Earth's surface. When this happens, precipitation occurs. Precipitation is any form of water that falls from clouds and reaches Earth's surface. Paragraph 14. Types of precipitation. The most common kind of precipitation is rain. Rain comes in various forms depending on the size of the water droplets that form, as seen in Figure 4. Rain starts out as cloud droplets. When cloud droplets grow a bit bigger, they become mist. When droplets reach a size of 0.05 to 0.5 millimeters in diameter, they are known as drizzle. Drops of water are called rain when they are larger than 0.5 millimeters in diameter. Paragraph 15. Temperature is a very important factor in determining the type of precipitation an area may get at any given time. In warm climates, precipitation is almost always rain. However, there are many other types of precipitation. In colder regions, precipitation often falls as snow or ice. Besides rain, common types of precipitation include sleet, freezing rain, snow, and hail, as shown in Figure 5. Take a look at Figure 4 here and see if you can label the drops as mist, rain, drizzle, or droplet based on their size. Now let's mark our text for this page. Paragraph 13. I found water is continually evaporating and condensing in the atmosphere, and this process forms clouds. I found that to be important and highlighted it. I highlighted the word droplets, and then gravity pulls them down toward Earth's surface. Precipitation is any form of water that falls from clouds and reaches Earth's surface. All of those are related, and they are really important. In paragraph 14, all I did was highlight our types of precipitation because 14 and 15 are really going to talk about that. Paragraph 15, I highlighted temperature is a very important factor in determining the type of precipitation an area may get at any given time. And then in the final sentence, types of precipitation include sleet, freezing rain, snow, and hail, as shown in Figure 5. Pause here if you need to finish marking the text, and then continue on. On this page, I'm just going to read through. Actually, we'll come back to this page, and we'll come back to that page. And I believe we are on paragraph 16 and 17. I'm going to mark that, 16 and 17. Please follow along as I read these paragraphs. Measuring precipitation. If a town receives a large snowfall, meteorologists need to track how much snow fell to determine how safe it is to travel. Similarly, if a big storm delivers a lot of rain, people would need to know how much rain fell to determine whether flooding might occur. Paragraph 17. Rain can be measured by using a rain gauge. It is an open-ended tube that collects rain. The amount of rain is measured either by dipping a ruler into the water in the tube or by reading a scale printed on the tube. Snowfall is usually measured in two ways, by using a simple measuring stick or by melting collected snow and measuring the depth of the water it produces. On average, 10 centimeters of snow contain about the same amount of water as 1 centimeter of rain. However, light, fluffy snow contains far less water than heavy, wet snow does. We've got a reading check. Determine central ideas. How are snow and rain formations similar? How are they different? Now, as you try to answer this question, please make sure that you're telling me how they're similar, using a complete sentence, and then how they are different. And again, use a complete sentence. Go ahead, pause the video, and come back once you've answered that question, and we'll mark the text. Nice job marking the text, and hopefully you were able to answer that reading check question. What I highlighted in paragraph 16 was meteorologists need to track how much snow fell to determine how safe it is to travel. It's really talking about why we do precipitation measurements. And in paragraph 17, I highlighted rain can be measured by using a rain gauge. Now, how are snow and rain formations similar? I answered it in red. Both rain and snow start as water vapor. How are they different? Temperature can freeze to make snow or stay warm and be rain. So that is how temperature affects it and changes and makes them different. Now let's take a look at paragraph 18. The water cycle. The water cycle describes the way that water moves through Earth's systems and affects our lives in many ways. As the sun heats the land, ocean, lakes, and other bodies of water, its energy changes the amount of water in the atmosphere. Through evaporation, transpiration, and respiration, water rises up and forms clouds. Rain, snow, and other forms of precipitation fall from the clouds toward Earth's surface. The water then runs off the surface or moves through the ground back into lakes, streams, and eventually the ocean. As seen in Figure 6, gravity and energy from the sun together drive water molecules through this never-ending cycle. Reading check. What role does energy play in the water cycle? Take a moment, press pause, and try and answer this question. Remember, reading checks come directly from what was just in our text. If you get it done, feel free to come back and we'll get ready to mark the text. For marking the text in this paragraph, I've kind of got a mess here, so let me erase it, make it a little easier to read. So we're going to mark the water cycle describes the way that water moves through the Earth systems and affects our lives in many ways. We've got, these are all going to be really, really important, so I'm going to make sure, I'm going to leave the underline, evaporation, transpiration, respiration, and precipitation. These are all parts of the water cycle. Gravity and energy from the sun together drive water molecules through this never-ending cycle. There is one more word that I've got on here. It's condensation. And what role does energy play in the water cycle? The sun energy makes blank happen. Gravity is important because, well, the sun's energy makes the water cycle happen. Gravity is important because, which if you take a look, we've got gravity and energy play a role here. Gravity pulls down that precipitation once there is enough of it. Okay, so that's pulling down. You can actually see it right here, up here. It's pulling down that precipitation. And we're actually going to label this. It's a little tough to see, but each piece of it we want to put in. So what we have happening here is precipitation. We've got our precipitation falling because of gravity. Now we've got our sun out here. We've got the sun that's causing some evaporation. So evaporation is going to go here. But down here you can see we've got some animals. That's the respiration that's taking place. And we've got the plants over here, the green. That is the transpiration that's taking place. So transpiration, remember, is the transfer from making water vapor from plants and things. So all of these things are part of the overall water cycle. Now, if we're going to take the time to mark the text and model it, it's probably pretty important that you get it down. Now that you're done, take a look at what you're supposed to do next.